All right, so today we will look at theory of production. The theory of production. We are done with the theory of consumer behavior, so we are starting with the theory of production. Okay, so at the end of this video, we should be able to answer the following questions. What is the production function? What is marginal product? What is average product? And how are these two production concepts related? And we also need to be able to answer the question as to what is the relationship between total product, average product, and then marginal product. And then what are the various stages of production? And then how are they related to each other? Then the output level that the firm produces. And then what is the rational stage of production? So out of the three production stages, which one is the most rational stage for firms to produce? And then what is the economic significance of the stages of production? So these are questions that after this video you should be able to answer. All right, so let's start with the production function. Basically, when we talk about production function, it's just it shows the relationship between the quantity of inputs and then the quantity of outputs that the firm can produce. So when you take the production function, it's able to give you a picture of the relationship between the amount of inputs that the firm needs to produce a given level of output. So that is one definition of the production function. In other words, it shows the technological, the functional relationship between the quantity of inputs used and then the maximum outputs that can be produced given a given period of time. Okay, given a period of time. So that is another definition of the production function. Is the technological relationship between inputs and then outputs. And then it also gives us a picture of the maximum output, as I said earlier, that can be produced given a certain amount of input. So the firm has the option of going for different kinds of inputs. So after the firm has been able to combine these various inputs, what is the maximum output that the firm will be able to produce? So the production function is able to tell us that. Okay, so I mean, when we sum all these definitions together, it just gives us the summary of technical efficient ways of combining inputs to produce outputs. Now, before you can produce any output as a firm, you need to combine the various inputs. But then there are some combinations of these inputs that wouldn't produce the efficient output that the firm will be looking for. Remember, firms only exist to make profit, so they are looking for this technical efficient combination that will be able to help them achieve this goal of maximizing profit. Now, the production function can be expressed in the form of a table, an equation, or a graph. Okay, it can be in the form of a table where we'll have the various inputs or the combinations of inputs at one side and then the output at the other side. And then for equation to it will be mathematically expressed, the relationship between inputs and then the outputs will be mathematically expressed, and then graphically to be able to show the relationship between the inputs, the quantity of input, and the quantity of output. So as we move on, we will see all these representations. So this is one way that we can represent the production function. This is an equation. So you see Y being the output level is a function of, we can have input A, B, C up to input Z. But normally we use capital and then labor. So the production function with output Y is a function of capital and then labor, where K is capital and then L is labor. Okay. Now, as I just said, if you are a firm, you only exist to maximize your profit. That is the main objective or the main goal of firms. Just like the consumer, your main aim is to maximize your satisfaction. So with regards to the producer today, they combine these various inputs just to maximize their profit. Okay, so they are looking for the most efficient combination that they can go for in order to get this optimum output that will maximize their profit. Okay, so that is the main objective of any firm. Okay, so let's look at some definitions. We have production technique. That is the particular method of combining inputs to make an output. Okay, so that is the technique. And then the technology is a list of all the known techniques that the firm is using. Okay, so when we combine the various known techniques that the firm uses to combine the various inputs in order to produce a given output, we call it the technology. Okay, so when you take the production function, we can define it as the list of all the techniques that are technically efficient. Okay, so if you take the production function, it's giving you the ways of or the methods of combining the various inputs, all the methods that are used in combining the various inputs to make a technically efficient, to produce a technically efficient output. Okay, so if you are a firm, how do you discover your production function? How are you aware? How do you know that this is how my production function looks like? Okay, in other words, how are you supposed how do you intend to know that these are the set of the technically efficient production techniques? If you are a firm, how are you supposed to know that? Okay, one way is just to ask those who have the knowledge about all these stuffs. You can ask your engineers, you can ask your designers, the economists that you have. They are able to determine the kind of techniques, the technically efficient techniques that the producer or the firm is using. And then you can also choose to do experimentation. So you use this technique. If it doesn't work, you use another one. So by using different ones, you're able to know the technically efficient ones. Okay, so the one that will yield your desired result, then you know that that is the technique that you have to use. Okay, the technique that you have to use. All right, so if you look at the table here, we have the various techniques, the outputs, and then the units of the inputs, capital, and then labor. If you take technique A, the firm uses 4 units of capital, 4 units of labor, and he's able to produce 100 units of output. If you go to D, he's using 4 units of capital, 11 units of 12 units of what labor to produce an output of 200. So these are various techniques that the firm is able to use in order to produce whatever output level that he wants to produce. So if you look at this, if we just wanted to produce the highest output, then technique D would have been the best, 12 units of labor and then 4 units of capital, so that we're able to produce the highest output. But the firm is not restricted to use any particular technique. You can just keep on changing the units of inputs that you use in order to change your output level. In order to change your output level. All right, then we have the concept of time in production. Okay, we have a concept of time. Now, if you are a firm, as we said, your main rationale is to make profit. And before you can make this profit, you have to be making decisions, economic or productive or production decisions that will help you achieve this goal. Okay, but you know that in this world we are constrained by time. The firm too has time constraint. Okay, the firm too has time constraint. The decision that you are making, I mean, it is time bound. So the time constraint that the firm is facing, it depends on the decision making period. Okay, what time are you taking the decision? What is the nature of the commodity that you are producing? That will, I mean, give us a picture of the time constraint that you have. Okay, so in as much as you want to achieve your objective of maximizing profit, you just know that um, you are time constrained. Okay, so to just get the maximum profit that you are looking for, you need to make sure that you are getting the perfect, the exact, the correct time frame to operate in, so that you'll be able to get the best, the highest profit that you are looking for. Okay, so basically when we talk about the time frame in economics, we are just talking about the period of time that a firm needs to make those productive decisions. Okay, we have various economic or productive decisions, like how much to produce, how how to distribute. Okay, what resources to use. All these are some of the productive decisions that the firm will have to make. Okay, the productive decisions that the firm will have to make. So based on this, we have three major time frames. Okay, we have the short run, we have the long run, and then we have the very long run. Okay, the short, the long, and then the very long run. So we'll take each one and then we'll see their definitions. All right, basically, when we talk about the short run, we are talking about a time period or a time frame where at least the inputs that you are using to produce, at least one of them is considered fixed. It being fixed means that even if you want to change your output level, there is no way you can change that particular input. For example, you are a farmer. You have a fixed portion of land, maybe 1 acre of land. That is the only land that you have. So even if you want to produce more, you cannot increase the land that you have. So the land there is fixed. So if you're a farmer and you find yourself in this situation where even though you want to vary your output level, maybe because of an increase in price for your commodity, you want to increase the output level, yet you cannot change the particular input, then it means you are in the short run. Okay, so if you look at the features here, it says that the ability to vary all inputs is limited. It is limited because you cannot vary all the inputs. You can vary some. Those are what you call the variable inputs, but some are fixed, what you call the fixed inputs. Okay. And what we need to understand is that this time period is not the same for all firms. Okay, it depends on the firm. It's possible that the time frame that firm A will consider short, we wouldn't be short for another firm. Okay, and then whether you are in the short run too, at times it depends on the kind of product that you are producing. That is what is going to determine if you can actually vary all the inputs that you have, or at least one is going to be fixed. So as I said, the fixed inputs are the inputs. They do not vary with output level. They are fixed. Whether you want to decrease or increase your output, there's no way you can change the quantity of those fixed inputs. So that is for the short run. And then for the long run, all the inputs, okay, all the inputs of production are variable except technology. Okay, in economics, when we talk about technology, we are talking about the method of production. Okay, as we just saw, the various techniques of combining the various inputs. So when you combine all your techniques, that is your technology that you use to produce. So in the long run, you can vary your capital, you can vary your labor, your raw materials, but then the technology, the set of techniques that you are using to produce, that one you cannot vary. Okay, you cannot vary. But here, the firm is a bit free when it comes to changing the output level. You can produce new commodities because you are now using a bigger scale. You can vary all the inputs that you are. If you have machines that are faulty, machines that are obsolete, you can just change them, and you can even just shut down and stop producing at all. Okay, so in the long run, you are free. The firm is a bit free to change the inputs that is using, except the level of technology. Okay, except the level of technology. And then for the very long run, all the inputs, even technology is also variable. So if you want to produce more, you can change, you can increase the level of technology that you use. So for the very long run, there is no limitation to varying the inputs that you use. You can vary all the inputs, and you can as well change the level of technology that you use. Okay. All right. Now let's look at fixed and then variable inputs. As I said earlier, for the fixed inputs, during the production process, their levels or their quantities are held constant. You are in the short run, you are producing. For these fixed inputs, it doesn't matter the output level that you produce, their quantities will still be fixed. If you produce 20, you will use the same fixed input. If you don't produce anything at all, you will still use the same fixed input. So it doesn't matter the quantity level. The quantity of fixed inputs are fixed. That's why we call them fixed. So during the production process, after the production process, their quantity wouldn't change at all. But for the variable inputs or factors of production, these ones are the ones that the firm can freely change. They can vary. So for them, there is a positive relationship between the variable inputs and then the output that the firm produces. Because if you want to produce more, is the variable factor that you have to increase so that you can produce more. If you want to produce less, is a variable factor that you have to reduce. So there is a direct relationship between the variable factor and then the firm's output level. Okay. All right, let's look at production in the short run. Why is production in the short run very important? Okay, one is very important because of the law of supply. Shortly, we'll see how production in the short run helps us define or derive the law of supply, and then it also helps us with the theory, of course. Later on in our next video, when we look at the theory, of course, you'll see how important the short run concept is. Okay. Now, the analysis of the production in the short run is based on the law of diminishing marginal returns. Okay, the law of diminishing marginal returns. We'll look at the law very soon. But before we do the analysis, let's look at some assumptions. One, the first assumption is that we are using only two inputs in the production process in the short run. Only two inputs, land and then labor. Okay, we will take labor to be a variable factor. Okay, and I'm sure you understand the meaning of labor being a variable factor. It means that if the firm wants to produce more, it's labor that he can increase. Okay, but land is considered a capital, which is K. So you check this, it's supposed to be capital here. So capital or the K is fixed. Okay, that one is fixed. And then the production function, Q, is the output produced, is a function of capital and then labor. But because we are holding capital constant, then the output will be a function of land. Okay, it's going to be a function of land since capital wouldn't vary. Okay. Now let's take this farmer. Let's use this production process. There's a farmer called Jack. He grows wheat. Okay, he has 5 acres of land. So we are assuming that these 5 acres of land is fixed. Now he's at liberty to hire as many workers as he wants. Okay, so the units of labor, which is the workers, is assumed variable. So here the land is what we are holding fixed, and then labor or the workers is what we are assuming to be variable. Okay. Now, if you look at this table is showing us the production function. Okay, the tabular representation of the production function. So the quantity of wheat produced is equal to the unit is a function of the units of labor. So if you look at this now, for the variable factor, if you don't hire any variable factor, you don't produce anything at all. Okay, you need labor before you can produce the wheat. So when output is 0, the quantity of wheat is 0. So if you come to the graphical representation, we have the units of labor on the horizontal axis, and then the quantity of wheat on the vertical. So when the number of labor or workers is 0, we don't produce anything at all. So wheat, the quantity of wheat too is 0. But when we hire 1 unit of labor, the person is able to produce 1,000 units of wheat. So if you come to the graphical representation, 1 unit of labor will produce 1,000 units of wheat. And then if you come here, 4 units will produce 2,800. So if Farmer Jack hires four workers, then they're able to produce 2,800. So if you come to the graph 4, you have what? 2,800 here. So this is the tabular and then the graphical representation of a production function. Okay. All right, let's look at the concept of total product or total output. We represent it by K or TP. Okay, so the TP is just talking about the total quantity of a good that is produced after the production process. Okay, after the production process. So you have combined the various inputs or the various factors of production at the end of the day, at the end of the week, at the end of the month, the year. What is the quantity of the commodity that you were able to produce? That is what we term as total product. Okay, so here with Jack's example, we are using only labor and capital. So after combining capital and labor, what will be the quantity of wheat that will be able to produce? That is the total product or the total output. So we'll depend on this total product to make the short-run production analysis. Okay. Yeah, apart from total product, we have marginal product. Okay, let me explain it this way. If you want marginal product, it's just the addition to the total product or the total output resulting from hiring an extra unit of worker. So when Farmer Jack hires an extra unit of worker, what is the increase or what is the addition to the total output or the total product? That is the marginal product. Okay, that is the marginal product. So if you look at what we have here, it says that when Jax hires one worker, his output will increase by the marginal product of labor. Okay, so when you hire an extra worker, then the total output is going to increase by the marginal product of that last worker that you hire. So per definition, it is the marginal product of any input. So here the input is labor, is the increase in the output. So here the output is the wheat, the quantity of wheat arising from an additional unit of that input, which is labor, holding the other inputs constant. So here, when we hold capital constant and we increase the unit of labor by 1 unit, then the increase in total output or the change in total output is what we call the marginal product of labor. Okay, the marginal product of labor. And mathematically, the marginal product of labor is calculated as change in output divided by change in labor. In other words, it's changing the variable product. But here, because we are using labor, the marginal product of labor will be changing output over change in labor. All right, so that is the mathematical formula for finding marginal product of labor. Okay, so right, let's look at how we calculate the marginal product of labor. This is our initial table: units of labor for the first column, and then the units of wheat for the second column. Now, initially, we're not using any unit of labor at all. So when we increase the unit of labor by 1, the change in labor there is going to be 1. The new unit of labor minus the old, so 1 minus 0. That will be 1. So change in L is equal to 1. Then when you come to the quantity of wheat, when we didn't hire any labor, we didn't produce anything at all. But when we hired one, we are producing 1,000. So the change in output here is going to be 1,000 minus 0. And that will give us the change in output, which is 1,000. So if you want the marginal product of labor, it's change in K divided by change in L. So 1,000 divided by 1 is going to be 1,000. So we have our 1,000 here as the marginal product of labor. As for the first one, we wouldn't have any value at all. Okay. Now, if you go to the second unit of labor, if you want to find the marginal product of that unit of labor, now you find a change in labor, which is 2 minus 1 here. So that will give us 1 as change in L. Then if you come to the units of output, you have 1,800 minus the previous one, which is what? Which is 1,000. So change in K here is going to be what? 800. So if you want the marginal product of labor, that will be change in K, which is 800, divided by change in L, which is 1. So we have 800. So that's what you do for all the other levels. Please, change in L is not always 1. It just happens that the difference between the units of labor here is always 1. It's not always 1. They can choose, we can move from 0 and come to 10 and go to 20. Then you know that the change in L is not going to be 1. So please don't think it's always 1. All right, so this is how we find the marginal product of labor. That is mathematical. Okay. Now let's look at the graphical representation of the marginal product of labor. How we derive the marginal product of labor from the total product. Now, the curve that we initially saw was the total product curve. Okay, the production function. The marginal product of labor is the slope of the production function at any point. The slope of the production function at any point. So if you take this point, then the slope at this point of the total product curve will give you your marginal product curve. How do we find the slope of a function? It's change in y, change in the vertical axis divided by change in the horizontal axis. So if we move from 0 to this point, okay, now the change here for the vertical is going to be 1,000 minus 0 divided by the horizontal, which is 1 minus 0. That gives us the 1,000. Okay, so all the changes, okay, the slope of the production function at each point will measure the marginal product of labor. Okay, so changing the quantity of output divided by change in the units of labor. That will give you the marginal product. Now let's look at graphical representation of total product and the marginal product. Remember we said we are holding capital constant. So if you look at this, when we didn't produce anything at all, our first input, which is capital, was still 10. When we produce 1 unit, it is still 10. When we produce 1 unit, it's still 10. When we produce 35 units, it is still 10. We don't change capital. But then if you look at total product and labor, if you want to produce more, you need to increase the units of labor. Okay, if you want to produce more, you have to. That's why when we're looking at the definition of fixed factors and variable factors, we said for the fixed factors, their quantities are held constant throughout the production process. But for the variable ones, they have a direct relationship with the output level. So if you want to produce more, it's only labor that you can increase. Okay, so increase labor so that you can produce more. And then the marginal product is measuring the change in total products as a result of a change in labor. So if you take this one, output level 16, the change in output here is going to be 16 minus 9, that will be 7, divided by this, the change in labor here is going to be 1, and that's 7 over 1 is 7. So that's how we measure our marginal product. Okay. Now, for this question, we'll look at it shortly. The relationship between total product and marginal product. But then this, is it logical to expand output beyond the 9th worker? I mean, when you hire the 9th worker, the person's marginal product is negative. If it's negative, it means he doesn't add anything to output. He rather reduces the previous output level. This is what I mean. When the 8th worker was hired, they produced a total output of 35. But when the 9th worker was hired, they rather produced 32. So you see that it was better not to, bring this 9th worker, because he's now reducing the output level because he has a negative marginal product. So it is not rational, it is not logical for the firm to hire the 9th worker because it comes in with a negative marginal product, and that means that it's going to reduce the output level of this firm. Okay, so we don't do that. We don't hire labor when marginal product is negative. Okay. Remember when we're dealing with the 10 principles of economics, we said that people normally think at the margin. So like consumers think at the margin, firms also think at the margin. If you are a firm, you are interested in the benefit that you get from increasing your workers by 1 unit. So if you take Farmer Jack, he wants to hire an extra worker. So if he hires this extra worker, what is the benefit, which is measured by the marginal product of labor that he's going to get from this extra worker? Later on, we'll look at the optimization of the firm. So we will know whether it is advisable for the firm to increase the units of workers or not based on the marginal product that he will get. So here the firm is also thinking marginally. If I increase the workers by just 1 unit, how will my output also increase? We see that he's thinking at the margin. Okay, he's thinking at the margin. So you consider whatever cost that you incur from hiring that extra unit of labor. Then you consider the marginal product, which measures the benefit that you get from that extra unit of worker. So if the benefit is more than the cost, then why not? You can as well go ahead and then produce. Okay. So we will get to that analysis. Now, if you look at the marginal product of labor, you see that it increases and then falls. Okay, it increases, gets to a maximum, and then it falls again. Okay, so the question is that why is MPL decreasing? Why does MPL diminish? Okay, now if you take the total product, if you look at total product, for example, you see that it started from 0, it increased up to 35. You see that 35 was the highest point, then it started decreasing again. I'm sure we can all see that. If you look at the diagram too, you realize that it will get to a maximum point, and then if you increase the units of labor, you see total product falling. Okay, so Now, when you try to increase the units of the variable factor over and over, you realize that it will get to a time where the addition to the total output becomes smaller and smaller. If the first person added 20 units to total output, you realize that the next person will add something which is less than 20 units. So that is one of the reasons why the MPL falls. Now, let's use this farmer as an example. You just have, I think it was 5 acres of land or 5 hectares. Now, you are hiring too much labor, too much workers, or too many workers. So, where exactly are they going to work? You see that if you have to divide the land, to these people, they will just be having smaller land to work with. So, because the fixed input is fixed, you don't have to hire a lot of variable factors. If you do that, you see that there will be a reduction in productivity. Okay, there's going to be a reduction in productivity. So that is why the MPL diminishes. Okay, after some time, after you start producing, after some time, when you keep on adding more units of the variable factor to a phase factor, you see that the marginal product will start to fall. So that is the law of diminishing marginal product. Okay, that is the marginal product of an input will eventually fall as the quantity of the input increases, holding the other inputs constant. So if you take labor and capital, we are using the farmers and then the piece of land. You keep on increasing farmers to a small piece of land, and later you realize that the marginal product, the addition to total product after adding an additional unit of worker or farmer is going to be reduced. So that is diminishing marginal product. And we can link the diminishing marginal product to the law of diminishing marginal returns. Okay, so what it means is that when successive units of a variable factor is added to a fixed input, then the marginal product of the variable factor will initially increase, get to a maximum, and then falls again. Okay, so if you take the labor and then the land, when you start adding units of workers to land, you see that there will be higher productivity. The marginal product of the workers will be high. It will be increasing, but then it will get to a maximum point and then it will fall again. Okay, it's going to fall again. So that is the law of diminishing marginal product of labor, diminishing marginal. Don't, if you keep on adding successive units of variable factor to your phase factor, the marginal product of the variable factor will increase, but then expect that it will get to a maximum and then eventually falls. Okay, eventually falls. Now, when you take the total product, initially it increases at an increasing rate, then it increases at a decreasing rate, and then it gets to a maximum and then it falls. Let me show you this. I don't know if you understand what it means for something to increase at an increasing rate. Let's take these two variables. We have variable x and then variable y. Okay, variable y. Now x is 2. We have 4. Then we have 8. Then we have 16. Okay, let's take this. And then for y, we have 2. We have 8. We have 12. Then we have 14. Now, if I should ask you about these two variables, I'm sure you can see that they are all increasing. 2, 4, 8, 16, they are all increasing. 2, 8, 12, 14, they are all increasing. But one is increasing at an increasing rate, and the other is increasing at a decreasing rate. Let's look at x. X increases from 2 to 4. So the increase there is 2. The rate of change is 2. From 4 to 8, the change there is what? 4. And then from 8 to 16, the change there is what? Is 8. So if you look at this, x is increasing, but then the rate at which is increasing is also increasing. So this one increases faster. So we say that x is increasing at an increasing rate. the rate of change in X is also what? Increasing. Let's look at Y. Y initially increased from 2 to 8. The change there is 6. Then from 8 to 12, the change there is 4. Then from 12 to what? To 14, the change there is what? 2. So even though Y is also increasing, the rate at which it's increasing is decreasing. You see that it's decreasing from 6, 4, and then 2. That's the difference between any two successive units. So we say that X is increasing at an increasing rate, but Y is increasing at a decreasing rate. Good. So now that you get the concept, let's link it to marginal product and then total product. Now, when marginal product is increasing, okay, it means that total product is increasing at an increasing rate, because marginal product is the rate of change in total product. So if the rate of change is increasing, then it means that the total product is increasing at an increasing rate. And then when marginal product is falling, it means that total product is increasing but at a decreasing rate. And then when marginal product becomes 0, total product will be at the maximum. And then when total product begins to fall, you see that the marginal product is going to be negative. Okay. Now, we'll come back to the relationship between the total product and the marginal product. Okay. Now, remember we said the short-term production analysis is very important because of one, the law of supply. Okay. We use the diminishing marginal returns to explain the law of supply. Okay. Now, you are increasing your variable input as against the fixed input. So we know that eventually the output is going to fall. Okay, the output is going to fall. So now, just assuming that the firm still wants to produce more, assuming there are people demanding this good, and the firm will have to produce more. As you want to produce more, you are increasing your variable factor. And because you are increasing it, the output is falling. There's a law of diminishing marginal return, so the output is falling. So because of this, before you can produce more and more, you need to increase the variable factor. You need to use a lot of variable factor before you can get a higher output level. And just know that as you are increasing your variable factors, you are increasing your cost of production. Okay, you are increasing your cost of production. Okay, so as you are increasing your variable inputs in order to produce a higher output level, you are increasing your cost of production, and this cost of production, this higher cost of production is going to translate into higher prices. So you see, we want to produce more, so we want supply to be high, and as a result, price for the good must also be high. That is why we have a direct relationship between price and then supply. When prices are high, supply to be high. And then if you want to, when supply is low, then price will also tend to be low. So you see how the diminishing marginal returns, the law of diminishing marginal returns has helped us know the law of supply. At a higher price, more is supplied, and then at a lower price, less is supplied. Right, we've looked at total product and marginal product. The last short-term production concept is average product. That is the total output per unit of the variable input. Okay, basically the definition is that assuming you are producing balls of kenkey, okay, you hired 10 people to produce these balls of kenkey, and they produce 50 balls of kenkey. So the question is that, on the average, how many balls of kenkey did one person produce? 10 people produce 50. So on the average, each person will produce what? 50 divided by 10, which is what? Which is 5. So each unit of labor produced 5. Each unit of labor produced 5 balls of what? Of kenkey. That is what average product measures. The per unit output that is produced by the variable input. Mathematically, average product is calculated as total product over labor over the units of the variable inputs. Graphically, if you want to measure total product, when you have your average product, when you have your total product curve, whenever you draw a line from the origin to the total product curve, the slope there, okay, the slope of that line will measure the average product. So let's assuming this is not drawn to scale. This is the total product curve. So if you draw a line from here up to this point, then the slope of this line is the average product at that point. If you draw a line from here up to this point, then the slope of this line is the average product at this point. So any line drawn from the origin to any point on the total product curve will measure the average product of that point. Okay, the average product of that point. So we are to use the initial data to get our average product and to draw the graph of average product so that we know how the curve looks like. Okay. All right. So please, if you do that, if you take total output 1, you divide it by the unit of labor 1. So your average product is 1. TP, which is 4, divided by unit of labor 2, that will give us 2. You see, 16/4 will give us 4. So the average product is just your total product divided by the units of labor. Okay, divided by the units of labor. So these are the graphs of the 3 short-run production concepts drawn together. This is the total product. This is marginal product, and then the red one is the average product. All right, so these are the graphs or the curves for the various short-run production concepts. Okay, TP, MP, and then AP. Okay. All right, let's look at the relationships between the production concepts: marginal product, total product, and then average product of labor. Now, let's start with MP and then AP. Okay, let me use the graph. If you look at this, marginal product and average product are all increasing up to this point. Okay, and when marginal product and average product are increasing, the marginal product increases faster than the average product. So the marginal product lies above the average product curve. I'm sure you can see this. Okay, and another relationship is that this is the maximum point of marginal product. This is the maximum point of average product. So you can see that the marginal product attains maximum before the average product. So that is another relationship. Then beyond this point, they are both falling. And you can see that the marginal product falls faster than the average product. So when they are both falling, marginal product falls faster than the average product. So marginal product will lie below average product. And another one too is that when average product is at its maximum is equal to marginal product at this point. Okay. And another one too is that marginal product can be negative, but average product can never be negative. Okay, it can never be negative. So those are some of the relationship. Let's look at total product and then marginal product. Total product and marginal product. Here, marginal product is increasing, so total product will be increasing at an increasing rate. After this point, marginal product starts to fall, so total product will be increasing but at a decreasing rate and gets to a maximum point. When it gets to a maximum point, the MP will be 0, and then as total product begins to fall, MPL is expected to be negative. So those are the relationships. When marginal product is increasing, that's the first one. When marginal product is increasing, total product increases at an increasing rate. When marginal product is falling, total product increases but at a decreasing rate. When marginal product is 0, it means total product is at its maximum. Then when total product begins to fall, it means that marginal product is negative. Okay, so these are the summary of the relationships. Okay, now the last thing we look at today is the stages of production. Okay, the stages of production. We have 3 stages of production in the short run. We have stage 1, stage 2, and then the third stage. Now, stage 1, I'm describing the stages. Stage 1 starts from where output is 0 up to the point where marginal product is equal to average product. And remember, that is the point where average product is at its maximum. Okay, so that's where the first stage starts from. Then the second stage starts from where marginal product is equal to average product and ends at where marginal product is 0. And you know that when marginal the curve is not done well, okay? When marginal product is equal to 0, it means that total product is going to be at the maximum point, okay? Marginal product is going to be at the maximum point. And then the third stage starts from where marginal product is 0 and total product is at its maximum, and it goes beyond that, okay? Now, the question that we need to answer here is that which stage is the rational stage of production? Which stage? Let's look at the stage 1. For stage 1, you see that 1, your total output is increasing. You have a fixed input. You started adding variable factors. At the beginning of the production process, you are using more fixed factors than the variable factors. So in other words, proportion wise, the fixed factors are more than the variable factors. And as you keep on increasing the variable factors, there's an increase in the total output, which means that it pays for you to add more variable factors. So when you're in the first stage, you don't stop there. When you keep on adding the variable factors, you are able to produce more or get a higher output level. So it pays for you to continue producing. Don't stay at stage 1. Now let's jump stage 2 and let's go to the third stage. At the third stage 2, you see that it starts from where marginal product is 0 and it goes beyond that, which means that if you keep on adding variable factors, the marginal product of the variable factor becomes what? It becomes negative. Okay, it becomes negative. The reason is that now you are using so much units of the variable factor as compared to that of the fixed one. So proportion wise, now the variable factor is also more than the first factor, and you are getting negative addition to total output as you increase the units of labor. So it pays for the firm to reduce the units of variable factor that he uses. So now, if you look at stage 1, you have to add more units of labor. If you look at stage 2, you have to reduce the units of labor. So they are all pointing to what? To stage 2. They are all pointing to stage 2. Here at the second stage, the two variables, the two inputs, that's the variable factor or input and then the fixed one, are being combined in their most efficient way. Okay, they are being combined in their most efficient way. And as a result, you're able to produce the highest output that you can ever produce. So it is economically wise to produce in the second stage. We don't produce in the first stage because the fixed inputs are more than the variable inputs. We don't produce at the second stage because, and we don't produce at the third stage because the variable factors are more than the fixed factors. We only produce at the second stage where the factors are combined in their most efficient and effective manner, okay, or proportions. And that's the point where the average product has reached its maximum point. Okay, it has reached its maximum point. And then you keep on producing until the marginal product, the total product will get to its maximum point. So when you get there, you shouldn't continue again. As soon as you begin to add additional units of the variable factor, then the total output is going to fall. So it's the second stage, that's the most rational stage of production. Okay, so this is where we end today. God willing, next week we will continue. We'll start looking at the theory of cost too. Okay, so we'll meet next time. Bye bye.